Thank you, Serpil. Thank you so much. Can you guys hear me? Yes. Well, first of all, thank you so much for having me here. I think there's such a great vibe in the room. I'm already excited. I think these gatherings are super rewarding for everybody. Not only from what you take, the technical insight, but the support and the encouragement and the vibe that happens in the room, right? And on WebEx too. And I'm really excited to be here. Today I'm going to talk about 5G, which what I'm calling an era of end-to-end transformation, and you'll see why I say that. I need to get the click. Okay, so I'm going to start asking you guys how many
5G.
of you know what 5G is.
It promises to transform our lives in all kinds.
Okay, a few, but actually I'll take this opportunity because I also want to, so Sandra Rivera, my boss, and someone that I hope one day you get here because she's awesome. And Sandra runs the whole 5G end-to-end at Intel. She's also the general manager of the entire network platform group. And she has a video. This is not a professional video, but it's a video that they go to New York Central Station, and they ask people what is 5G, and then you get all kind of, and it's really cute and funny, and you get all kind of answers. But there's one that we love, that is somebody that said, "What do you think is 5G?" And she said, $5,000. Yeah. So, you see that? So I think it's, so anyway, we're going to start with what is 5G. And in a very simplistic way, right, I tell you what 5G is. And I tell you right away that I'm not going to make it justice because it is so much more. And it's such a revolution, such a leap in technology. But 5G is basically the next generation of wireless networks, right? With 5G, we're going to provide higher speed, greater reliability, lower latency, greater capacity. And if you think about it, we came from a long way from the first, if you remember the first mobile phone, the first text, then we got in 3G into online, and all the apps showed up, and it was an app revolution, and then 4G with all the speeds and the faster rates than we enjoy today. Well, 5G will bring all this. Will bring more higher, still even higher speeds and low latency and high reliability. And it also will provide the opportunity to connect million of devices, right, of things. And I'm going to add million of smart things that will be able to be connected, and I'll tell you why I say that later. But it's also provide the possibility of distribute, and requires not only provide but requires to have a distributed analytics and distributed intelligence across the entire network, right? So this is what 5G is. But again, I told you I was not going to give it enough justice, so I'm going to play a video for you that I think is really, really cool. So I think I have to do a click, and then I have to play from here.
5G. It promises to transform our lives. It promises to transform our lives in all kinds of different ways. But what is it exactly? It's often described as just the next step in the pursuit of an ever faster network. But in reality, 5G is much, much more. It's an entirely new technological foundation, purpose-built to support the next great wave of life-changing digital advancements that will be enabled by our smart and connected future. From the safety and environmental benefits of autonomous driving, to dramatic breakthroughs in artificial intelligence via machine learning, and a whole new era in healthcare, to a smart and connected revolution that will transform agriculture, manufacturing, cities, and our individual homes. Even virtual and augmented reality. Every one of these promising new breakthroughs will be built on the common foundation of 5G, enabling billions of things to be made smart through seamless connectivity, massive computing power, and access to rich data and analytics stored at the eye of the cloud, all of which means one company is uniquely positioned to power 5G end to end. Intel.
Much more cooler description of what 5G is. So when we talk about the future, and we talk about 5G, and we do that because the future, we see the future being about data, massive amount of data that is going to have to be collected, it's going to have to be analyzed, it's going to have to be converted into value, and also into monetization of that data. Think about it. We believe that in 5 years, 70% of the human population, 70% of the human population will have some kind of a smartphone, right? And if you look at what we're thinking, we know it's a little bit, what is this? Hold on, it's a little, let me go back. Yeah, that is slide for, it's a little bit, okay, all right, so, but,
was it animated?
No, it was not animated, but it's a little bit, it's okay. Well, we can see it there. But anyway, in 5 years, right? In 5 years, what we see, but that, so the 70% of people with a smartphone, with a mobile phone, and that's just data that we generate, right? That people generate. That compared to what things can generate is nothing, right? In 2020, we believe that in 2020 there will be 50 billions of connected devices, right? So half 2020, right? Half of the data that is going to be generated not by humans but by things, and that's a tremendous amount of data. Think about it, and the slides is a little bit messed up there, but the average internet user generate 1.5 gigabyte of traffic a day. Now, I don't think I have to say this. I don't know how many of you, they don't know my daughter. I don't know how many of you have a preteen daughter that use something called Musical.ly. Anybody knows that? Yeah. Oh my, well, that's definitely not enough for her. But anyway, back to this. Average internet user, 1.5 gigabit. A autonomous vehicle, 2,500 times that amount, right? 4 terabyte. A connected airplane, 5 terabyte. A smart factory, 1 petabyte. Tons of zeros in there, right? So you can see the amount of data that needs to be collected from sensors and chips and smart appliances in homes and cities, and you name it. All that, you have to believe that we have to have a better network. The network that we have today is not going to be enough. We have to have a much smarter network to deal with that kind of data traffic. When we look at that, and we believe, by the way, that of course that the solution to that is precisely 5G. When we look at 5G, one of the most impressive things of 5G is the amount of use cases that are already being generated, right? There's tons of super cool use cases and services, and there's many that we don't even know that what we don't know yet why they are. But what we can see is we can put all those use cases in 3 major categories that have very specific, different type of requirements. So we start first with first group, the massive machine-to-machine use case, right? This is the case where it doesn't require a lot of bandwidth. It's not especially sensitive to latency, but there are millions and millions of devices that have to be collected, aggregated, and then convert in value and do something with that. And that's the challenge of that use case. Secondly, an example of that, let me tell you, an example of that could be, again, a smart home, smart cities, you think about the smart traffic, smart parking, that kind of stuff. The second case is the enhanced mobile broadband. And that now you can think of everything, the whole virtual reality and augmented reality and the 3D glasses and the VR glasses. And so that requires a lot of more higher bandwidth, and it requires low latency also. There is also the last mile, what we call the last mile, how to get wireless connection directly to your home. That last mile of few yards to your home, that's also part of that. And there's trials going on around that. And then the third case is the ultra reliable and low latency. And these are cases where we're talking about faster, very, very fast response, sub-milliseconds kind of response, mission critical kind of applications. For example, surgery, remote surgery. You definitely want fast response there, or the autonomous driving. That was the autonomous driving, where you need very fast responses if you have to change lane, if you have to avoid collision, that kind of thing. So those are the type of the three categories. Now, again, so many use cases. One of the things that you can tell with 5G, never before a technology platform was asked to provide to address so disparate user cases and applications. It's all kind of there's all kind of services, all kind of verticals, all with different requirements, and all that has to be covered by the network. And then again, that tells us one more time that the network has to be transformed and has to become much more intelligent. So I'll mention a few of the use cases because I think they're really cool. But for example, in the ultra reliability and low latency, the drones, right? Drones are fun. It's everybody likes fun. I mean, like drones. My son wants a drone. I don't know why, but he wants a drone. A lot of it's very cool, but it's also very, very useful, right? They're used already. They're being used for photography, for surveys, for inspection, right? To get access to inspect areas that are hard to get access to. You could think, for example, and in the past few weeks we have way too many natural disasters, and one is too many natural disasters. But you could think how the drones could help in a situation like that, where they can, number one, they can go and inspect. If there is an area that is hard to access or the conditions are rough, the drone can go and inspect the area and see what's going on, but it can also bring supplies and if needed, or it can even help in the evacuation of people. So look at all the good stuff that can come out of that. There is also, and AT&T has a trial on this, where they can reproduce it. Let's say that because of a natural disaster, again, the whole cellular infrastructure is damaged or wiped out. They can reproduce the entire cellular infrastructure in drones, right? So that's pretty cool. There is other case, for example, it's not only goes to the enterprise to this. Another super cool example, we're working with Airbus, and Airbus does aircraft inspection, right? They have to do aircraft inspection, and they have to through the entire year, right? So normally the traditional way to do this is a few guys or people in a cherry pick that goes and go around the plane and inspect the whole plane, right? Well, they went ahead and had a project where drones did that, right? What it used to take 2 hours with the people in the cherry pick, 2 hours become 15 minutes. But not only that, now you have all that data that you can build your database, you can collect all that data, build a database, and make some intelligent decisions based on that, on intelligent judgments based on that. So you have the drone locally collecting information, locally doing inference of that data, but also a database stored in the cloud that can be referenced to, and now you have the whole artificial intelligence embedded in that example. So that's one example. Again, we could talk about the autonomous driving, just to put it in perspective again for what it means 5G. So in autonomous driving, to avoid collision, you have to, you need a very fast response between the car and the network, right? To avoid collision, you need 3 milliseconds. That round trip communication between the car and the network has to be less than 3 milliseconds. Today in the 4G network, when we try that, it's 50 milliseconds, 50 milliseconds, right? 5G can get that down to 1 millisecond. And that's why there's so much excitement around it, because 5G can really make this possible. There is some other example. I talk a little bit about the smart city, just to pick one. And there is what we know of a smart city, and there have been prototypes, in the world. China has definitely, there are many examples in China where you have smart lighting, smart traffic, right? Cameras are connected, and then it goes a little bit into the third category with more bandwidth. But I want to share this with you, because I was looking for a few examples, recent examples in preparation for this talk, and I found this project, I guess, in a city. This is in China, where all the cameras, is a lot about face recognition, and there's all the cameras are connected, and but the thing, and okay, I understand that, and they're used for surveillance, right, and to catch the bad guy, and I had heard about that before. But the thing that I haven't heard before is that they have this in prototyping, where they link your face to your bank account. So, wow. So when you go to a store, that's what you pay. You pay with your face. You come out, you can get out whatever you want, but your face is paying, right? And the boss, you go into the boss, and your face, you pay with your face. So a lot of I can't remember who I was telling, but it's we're talking about things that not that long ago, it was almost science fiction, and now it's all that is happening. But anyway, and then in the last one, just to all the virtual and virtual reality and augmented reality. How can you get a virtual, a physical object, and put it in a virtual world, and the opposite, right? The virtual object in a virtual object in a physical world, and a physical object in a virtual world. The lines are so many possibilities. My favorite there is this is what I'm waiting for, and I'll say two things. But the first thing is that I know there's a lot more important things to take care of, and that I wanted to happen. But I tell you one that I can't wait for it. For a long time, I have been wanted to climb Mount Everest. Now, let me make it clear: I have never ever in my life have been in any physical or mental shape to do that, right? But I'm excited. I'm fascinated by that. I read all the documentaries. I watch all the documentaries, read all the books, watch all the movies. Fascinated by that. But I know it's something that I would never either was able to do, or definitely will never be able to do. But I can't wait for that experience where I can climb Mount Everest. But I want to feel it the whole way, right? I want to feel the heavy breathing, and the heavy equipment, and the hooks, and the ropes, and the bike. And I'm going to take my sister with me, who never in her life has run 1 mile. She's coming with me, and I know I'm going to have to help her a little bit, but she's going to make it. And we're going to get to the top, right? And I know exactly how it all planned. I'm going to get to the top. I'm going to see the view. I'm going to enjoy the view. I'm going to put my flags there. There's going to be several flags, including probably an Intel flag, because we're doing so much for this. And that's it. I'm not going down. I don't have to go down. All I have to do is, I wanted to go to the top. I don't need to make it all the way down. So that's my silly little hope. But anyway, so that's all the possibilities. And then again, you have to monetize this, right? Because it's important that we create the business and the, we create data monetization, so this makes good economics, and the more economic sense that it makes, the more applications and the more effort is going to go after that. This is 5G in action, just an eye chart, everything connected, people connected in all kind of ways, from devices, from everywhere, the city all connected, the cars all connected, the industry all connected, right? So this is just a cool picture. Okay. Explosion of data, we talk about that, all the different applications. But the thing with here is that all these billions of devices that are gonna be connected, again, they're gonna have intelligence that are gonna power artificial intelligence, and it's going to be able to make much more, so to be embedded, to get that intelligence embedded from the access, the edge, and the core, and then it's going to open all kind of possibilities because of that intelligence and that is distributed, and that analytics that is distributed in the entire network. Okay, so let's stop here for a second. So 5G, all these great use cases, right? But there is a fundamental radio technology that need to happen in order to that. There is the entire network from access to edge, from access edge and core, but there is also the radio part of this. And I think I skipped one. Okay, all right, so maybe I didn't. Okay, I think I added that slide later. I'll talk about a slide that I wanted to have there, but I'll talk about it fast, so you know how we got to this one. So most of the phones and the electronic device that we use today, they use sub 6 gigahertz frequency, right? So you have sub 6, that's the spectrum, right? And that's great. That gives you miles of capacity and coverage, and all is good. But what happened is everything is in that sub 6 gigahertz, so it's getting pretty crowded. The spectrum is getting crowded. So it was important to find new ways to get bandwidth, right? And unfortunately, a lot of research and a lot of development went into it, figuring out that how to get this additional spectrum, additional capacity, bandwidth. And then now we can use 5G, can use frequencies above 24 gigahertz. And that's what you hear, that's what is called millimeter wave, right? Now, we all know, right? Higher frequency, smaller length wave, the signals don't travel as good as in lower frequency. So that presents challenges, right? High frequency are more prone to degradation. It's a more hostile propagation environment. That's a challenge in itself. So that's why the antenna side of this is so important and such a key component of 5G. And part of that is 5G new radio is that there's two technologies that I want to talk about it. And one is the massive antenna arrays. You will also hear something called a massive MIMO, massive multiple input, multiple output, MIMO. And what we do with this is you have now, instead of being two antennas or one receiving, one transmitting, you have multiple antennas transmitting and receiving in the same frequency band, right? So you're pumping data in the same frequency band, and that gives you not only more throughput, but it gives you less latency and more robustness. So this is the massive MIMO is critical. It multiplies the wireless capability. Now, if you take, that's one technology, but this is also making possible to create another technology that is called beamforming. Beamforming. So beamforming, what it does is, again, it's a very hostile propagation environment. So with beamforming, that technology allows you to selective, directional, transmit and receive to a user, right, and minimize the interface, minimize the degradation of that signal. When you are pumping directly, you are focusing on it, you are beaming into a user, and that beamforming is super critical. This is, for example, there are many examples of where this has to be used, but I have one that will impact me every year. We have this couple of big music festival. I'm from Austin, Texas. So we have, I don't know if you guys have heard, but we have South by Southwest and we have Austin City Limit. And this is tons of people open in an open area, right? But there is always a little bit of challenge with the signal because there's so many people, and Austin is, there's a lot of geeks in Austin, so everybody, and everybody, right, using their phone. Or this happened also in Vegas, right? When there is a big convention, convention, and you're outside, and still you have problems getting a signal. So this could help with that, just being able to direct, selective, directional, transmit and receive to a particular area, and that should help with that. So these two, the massive MIMO and the beamforming are critical to the 5G. Okay, so far we covered the use cases, we covered the radio side of it, but everything that we have talked about it again just reinforces that what we need, what we have today is not going to be enough, right? Today we have a network that is a homogeneous network, whatever one network fits all, and it's just with so many use cases, so many different requirements, so many expectation and so high expectation of the quality of the service, the quality of the experience. It's just we are going to need a much more intelligent network distributed across the entire network, and that's what we're saying, right? We're saying two things. Number one, this is happening, or I guess we're saying three things. Number one, this is happening. Number two, the work is now. We have to get this going. We have to get probably faster even of what we're doing right now, and we have to get to a point that we do these three things, right? Number one, we move that intelligence again to the edge and to the access and not only the core, but obviously a core too. The distributed analytics have that programmability, the capability of have programmability, so it can be scaled and it can be optimized in the entire network, and then the open source and standard. This is important because it is what having open standards and open source, it lowers the barrier, right? Makes it more cost effective. It makes it more accessible. It create innovation, and it motivates innovation. So that's what we're talking about. And I'll go, the next slide will go a little bit more into this. Okay, all right. So what we're talking about is the legacy, let's call it the legacy network, right? It's a network that is a custom network, is proprietary, is hardware defined. So we're already this is happening already, going into a modern cloud ready network, and that is software defined and agile and open, and you can have network functions and virtualize it, and there's no proprietary. You don't have to deal with multiple proprietary configurations. That's the modern cloud ready. Now the next step is to take that and go to analytics and cloud native, and and have, again, the analytics is code from the core to the edge, and have visual cloud there, and have network slicing, which is a fundamental technology of the future network. So I'll go into a couple of those a little bit more in details. So this one is about software-defined infrastructure, and so what we're talking about here is a case where, or is when the operators can define the application and define the policies, and then the network and really the orchestrator is capable of configure and provision the network, right, by itself. And we're talking about a network that is smarter, that is self-aware, self-scalable, self-optimized, self-healing, right? And the way this happens is you have the orchestration software, you have the orchestrator watching telemetry that is coming from resources that are monitoring the network and monitoring the services. And if the demand, if the service demand changes, if the conditions of the network changes, that orchestrator can right there at runtime, on the fly, make a decision and act on it, and pull different resources or adjust the resources in whatever makes sense, so they can so the network can maintain the quality or the requirements that are required for the particular service. And you can see, by the way, a step ahead of this will be now this network also is learning. There's machine learning going on there. So now the network is learning what works, what doesn't work, what is best, what is not best, what happened in the past, it can learn about it, and then it can take actions based on that. There is artificial intelligence embedded in that too. Network slicing. This is super important. So the network slicing, it basically tells you that you have logic. You take your network, and you take your network and you slice it based on services, right? We saw the different use cases. Not all the use cases have the same type of requirements. You see there high bandwidth, ultra low latency, low bandwidth, ultra high bandwidth. There's so many different cases. So with this logic slicing, you can put guardrails. You can decide the service what kind of characteristics it's going to have, and what do you want to protect for that service, and what kind of requirements we're going to meet, and what kind of experience you're going to give with the service. I'll give you a typical example. So let's go back to the autonomous driving, and this is an example, right? There's an autonomous driving. There's a autonomous vehicle, and I did like this with my hand, but I actually wouldn't be holding the wheel. There's an autonomous driving car, and the car is driving by a college campus, right? And there's a bunch of kids there downloading and uploading video at that particular moment. You don't want to jeopardize the quality and the reliability and the bandwidth that you need for the autonomous car. So you put that in a slice. You give a slice to the car, and you give a slice to the kids in the campus, and then you protect that nothing, no matter how much in campus they're downloading or uploading videos, the car is not going to get the service that you have to give to the car is not going to get jeopardized. That's the fundamental of it. Then the other aspect of this new approach to the network architecture from end to end is how we have to move that intelligence to the edge, right? Because you have to bring that computer and that intelligence closer to where the application is, closer to where the end user is, and that, to begin with, that will unleash all kind of possibilities on all kind of services and experiences. I'll have another example here. You can guess this, but I'll throw the question out there. What do you think at Super Bowl? If we take a Super Bowl in a stadium, right? Stadium, Super Bowl is going on, Windows Day, traffic peak happens. I tell you, it's not in the touchdown, right? It's not when the touchdown happens, it's at the halftime, when everybody's uploading Lady Gaga and the Intel drones show and taking selfies and uploading some more. That's when it happens, right? And it's, you can see, a spike on the traffic. So rather than provision, the network in a way that will to deal with that will be too costly, you could have a virtualized radio access network, VRAN, a virtualized network access radio, right there, a network, radio access network, right there in the stadium, catching the content and dealing with that traffic peak without incur in the cost and the latency that will imply if you have to take all that to the core. So these are, and there are multiple cases. There are cases you could say the same about, an ambulance and the hospital and how close you can get to that person that is being transported. There are multiple cases like that. Okay, so what we're talking about here is, again, if you look at the end-to-end, you see that there is virtualization, there is intelligence, there is analytics distributed all the way from the edge, the access, the edge, and the network, with the network slicing being there in the whole, end-to-end network. Okay, so we love this picture. So we believe that there is a lot of opportunity in 5G end-to-end, right? There is a lot of opportunity, and there is an opportunity and a need here to transform that network end-to-end. We call this, and the first person that I hear to call this picture like that was Sandra Rivera. I was just talking about her, and I'm gonna try to not trip myself with the words, but we call this a circle of cycle goodness. And I love it, right? Because it really represents, is from the content creation at the smart device, or the at the thing or the user, all the way through the network, what is happening there, the analytics that is happening, the artificial intelligence that is happening there, creating service up and down, all the way to the cloud, and then back, right? So that represents the whole end-to-end and the value that is generated there. Oops, clicking the wrong button. So let's put it all together. So this is the same circular cycle of goodness. I think circular cycle of goodness. Let's say it again. What happened there, right? So we have at the cloud, and this is an autonomous driving example, right? Take an autonomous driving example and see what happened with the circular cycle of goodness. So the first thing that happened in the cloud, there are powerful analytics required to make sense of massive data from moving vehicles, right? So it goes to the core network, and then there we have slices that separate that car so that service is protected. Then we go to the access network, and we have all that intelligence brought up to the edge to minimize latency and have it closer to the application. We have all the radios that allow the car to be connected with other cars and to be connected with everything, right? To everything, basically. And then we have the smart that is happening inside the car. That is an end-to-end goodness, and how everything comes together, and how that network from one end to the other has to be architected, has to be taken a new approach so we can facilitate that. So I'm getting to the end. So this is, I guess I want to end saying this is 5G, is happening now. It's going to change our life, no question about that. We need to get ready for it. We need to create the infrastructure. We need to create the network that is going to be able to to support all these use cases and all these requirements. And the faster we go with that, the better. And I think it's a really exciting times ahead of us. And and when I say end to end, I mean network, cloud, and client. And that's it.
And with that, we're going to open up for questions. We have enough time to ask anything. And please speak to the microphone so the remote participants can hear.
We do have one question from the bridge. How does the 5G slicing differ from the 4G QoS options? Doesn't 4G support multiple traffic templates and QoS options?
Yeah, that's 4G. Definitely, there's many ways to deal with quality of service in the 4G, but you're still competing for the same network, right? You still have, if it's the same. Go back to the case of the car driving by the campus. That network is going to be that one application is going to be competing. If that happens in 4G, one is competing with the other, right? So what slicing provides you is that logic separation where you can guardrail that and provision provision that service with the exact requirement that is needed. So you can give to that application higher bandwidth, ultra reliability. You can protect. There's no competition with other service that might have a different set of requirements. Okay, please. Oh, you okay?
Yeah. Hi, my question was one of the use cases. You mentioned all the smart devices being connected through 5G, which in the present world are being done by different technologies, like Bluetooth is there, and the Wi-Fi is there, and then this LTE and 4G system. So does it mean that Wi-Fi, Bluetooth won't be there in the future when 5G comes up, or those technologies will deteriorate?
No, that's a good question. I think there are going to be multiple technologies living together. I think it's going to be an heterogeneous network with all of multiple different technology present, right? There are going to be some that are going to be focusing indoors and some focus on outdoor, and depending on the conditions. Also, it's a big city, if it's in the rural space. So there it's going to be an heterogeneous, but the key fundamental thing is that the network has to be prepared to deal with whatever the data creation and whatever the transmission of that data happens. The network in the back has to be able to deal with that and differentiate the service so it can give the right quality of service.
So my question actually dovetails on your question. Were there any new protocols developed specifically for 5G?
So 5G is emerging, right? And I think it's more than emerging. It definitely has to be standardized, and there is many people working on that. I think I was talking to recently with somebody that was telling me, at the beginning, we were just thinking, let's have something now. Let's have something. What could be something 5G, right? And by now there are many requirements, very high demanding requirements, and it's taking form. So there are many bodies and many peoples and many efforts going into the standard. And yes, we have to get to that point that get standardized. Yes. And it's emerging, right? And it's changing, but again, it's getting settled, and it should. Please. Oh, yes.
Hi, thank you. That was a wonderful presentation on
Thank
the overview of 5G network. A quick question, do we anticipate any challenges when everyone starts adapting the 5G networking?
Any challenges when
everyone starts adapting or going to 5G network?
I'm sure there will be
challenges.
I'm sure there will be challenges, and that makes it even more exciting.
Yeah.
There are challenges, right? There are many different technologies that are that are being developed now. A lot of efforts going into different from the radio antennas to each piece of the network. Every piece that has to come together, and just changing the entire architecture. Right? We're talking here about doing things in a different, right? We're changing the way we thought before, and that itself, just changing that is a challenge. We have to, we can't throw everything away, right? So the legacy network still has to be there, and the legacy technology has to be there. You look at just we're in 4G, but there's still 3G systems out there, and 4G took a long time to ramp up. So there's going to be a lot of technologies that are going to live together, where there are going to be new things right away. There are going to be things that are going to take a little bit more time. Challenges, for sure. Impossible challenges, I don't think so. I think we are at the technology level and at a mindset level that that this makes possible. It's also the economics that come with this, right? This 5G will imply, a good economics and a creation of business and goods for everybody. And I think now the enterprise and everybody has an interest on that, because they see the possibility to create a monetization out of that. And that's an important. We're going to have a lot of people behind us and investing on it, making it happen.
Hi, I'm Surabhi, and I started work at Cisco just yesterday, so this is my first women in technology event. I'm very excited, and thank you so much. Your presentation was amazing. So my question is that we're seeing that the number of devices is so high. Basically, everyone is connected to everything, and the amount of data is also very high. So what can you tell about the privacy and security of our data in the 5G network?
It's definitely something to take it's a consideration, right? And I gave you an example of the whole face recognition, right? Where do we throw the line there? And it's a question that is out there. Obviously, security in the network is a concern and an important aspect to anybody working on this. I'm not an expert in security. I hope I could answer this in much more depth from the technical point of view. There are other people, I'm sure, that can talk more about it. But it's part of it, right? It's part of the equation, and it has to be solved. And I know there are many people working to solve those problems and to figure out, right, what are do they need to be guardrails, and how do we do the right things, or what we believe are the right things.
Actually, we have a few questions from the bridge. One question regarding the self-learning network. Where are we in this area, and do we have any application of machine learning already deployed in the network?
I know for sure there are many examples, and we definitely Intel is working on that. But from the deployment point of view, I actually don't know if we have anything deployed right now. It's something I can investigate a little bit more. But yes, it is definitely the entire artificial intelligence and we for sure we're working with many people on that, and I know there's other people's working. There is so much opportunity in machine learning, and what can be achieved, and the capabilities of inference. Once you can collect the data, and you can apply analytics to that, and you can make sense of that data and use it to inference and make decisions. You have the network and the compute power that support that. There is so many possibilities. It's definitely one of the most exciting topics on around 5G and the future, for sure.
So another question is, does 5G depend on or limited to the millimeter wavelength, higher frequency medium, or is that 5G can leverage a broader range of frequencies?
Absolutely, yes. So there is 5G at sub 6 gigahertz, right? That's and there are trials going on right now on that, right? There are trials out there that are happening. Again, this is going to be an heterogeneous network, an heterogeneous system that will use the sub 6 gigahertz and will use the millimeters wave, both of them, and will use all the other technology that was mentioned before. Yeah.
So when do you expect to see 5G network deployments?
I can't wait for that. I can tell you that. So there's two big. I don't know if you heard about this, but there's two big milestones that are in front of all of us. So there is the Olympics, the Winter Olympics at Seoul, right in Korea, and we expect everybody. There is an expectation there and a commitment there to have some deployment of 5G in the Olympics, in the Winter Olympics. That's 2018, right? Now that's going to be a small scale, right? Now the next Olympics, the Summer Olympics in Tokyo. Now there is a bigger expectation that we'll see much more 5G in a larger scale being deployed. So yeah, we're talking some small deployment in 2018. Starting to, you will see more in 2019, and then ramping up to 2020 plus. Yes, very exciting. Can't wait for that.
Thank you, Cristina, for coming to speak with us today. Fabulous presentation.
My
I
pleasure.
especially like your autonomous car example. So using that example, what role do you see Intel play in terms of providing those capabilities?
Oh my gosh! So we're doing so much in all the areas, right? Obviously, where I sit on in the network platform group, and I'm the network customer in the Sandra's network platform group, in the data center group. From the network point of view, having the capability to deal with all this that we're talking about, the network function virtualization, being able to have completely virtualized network functions, software defined. We're working on all that and providing reference for that. We're working on something called FlexRAN, where we can bring where we can bring that intelligence to the edge and to the access, and have the same kind of programmability and flexibility in the entire network. So we have you probably know our DPDK packet processing software. A lot of efforts is put in there so we can have the foundation, the right packet processing foundation. So that's just in the network, right? All kind of stuff going in the network side. But then if you look around, we are definitely participating in autonomous driving. We have multiple partners with that. We're definitely working also with artificial intelligence. So from Intel point of view, we see again data being the future. We're heavily committed to have a presence in the data and drones. Of course, you're seeing our drones out there too. So heavily committed in 5G. Very big believers of the reality of it, the possibilities of it, and the fact that this is happening, is going on, and we better get ready. And we want everybody. We want to work with as many partners as possible. We want to make this. This happen.
With Cisco being one of them.
I'm sorry.
With Cisco being one of them.
Of course, of course, we are partners. Absolutely.
So a couple more questions from the bridge real quick. Are there any anticipated spectrum crunch issues? Are any of the legacy bands being repurposed in advance for 5G?
I'm not familiar with that. We're definitely going to continue using the sub 6 gigahertz. And then, once you go to millimeters wave, you have plenty of bandwidth there. So I don't expect a problem. I personally don't believe there is a problem. There are people that definitely will know more about that than me. But I don't see. It was getting a little bit crowded, right? And if we wanted to do this 5G, we wanted to the kind of tasks that we have with 5G and the kind of ideas and use cases that we have with 5G, we definitely needed more bandwidth, and that's what millimeters wave bring in the picture. But I think we're going to be. Bottom line, I think we're going to be fine, right?
One more quick question from the bridge. Will quantum electronics be available on a wide scale for 5G?
Interesting question. I know there is a lot of work being done into that. I'm definitely not the expert on that. So 5G again is open so many possibilities, and I'm hoping that will be one of them sooner or later, but that will be at some point there.
Thank you for that talk, Cristina.
Of course.
My question was that technology is now creeping into our lives much more than before. It's one thing to have it for frivolous things like social networks and everything, but when you're talking autonomous cars, healthcare, banking, more and more important things that we'll be doing, how do you address reliability of your networks and the fact that they should never go down, and how do you address that?
Yes.
That's increasing much more than before.
And exactly, right? And that's one of the things, if somebody is performing a surgery remotely, that network better doesn't come down, right? So it's definitely that's what one of the cases is single highlighted as high reliability, low latency, right? It's important that the network, that the reliability is there for the cases that that require that kind of mission critical conditions, right? You can see, for example, and this is one example that I just think about it with. When you go to a cloud native kind of approach and architecture, where you not only, when we talk about the software defined infrastructure, the orchestrator was looking at how to pool resources, right, in different cases. But in the network slicing, you could see, and in a cloud native environment, you could see how a service could be moved to another place, right? So if one network goes down, can that service move another, and can it be done fast enough to not create any kind or meaningful disruption of what happened? So again, it's all there. That's what, when we say the approach has to be different and much more smart and much more intelligent, all that has to be taken into account. Network reliability, especially for the mission critical, is fundamental, right? But that also helps, it's also, I believe it's also the distributed analytics and the bringing the compute and the network closer to the application will help too, because now you have all these networks, all these networks close to the application in multiple places, and then that should give you also more flexibility.
So, Cristina, what do you think is the future of Wi-Fi in conjunction with 5G? Will 5G replace Wi-Fi, or will they both continue to cohabit side by side?
That's would it replace it? I don't know. I think right now what I see is a network, is a world where there are multiple technologies living together. At least at the very few next year. What is going to happen later? Things might change. New things might come up. Wi-Fi might evolve to something, to a next step. I don't see right now anything disappear, but mostly I see everything going to a next level and evolving and transforming to the new world, to the new 5G.
Can I ask the last question?
Yes, please.
Are there any joint projects going on between Intel and Cisco around the 5G that you're aware of?
I think we're great partners, right? And we work together. I know we are working together in many things. I don't have any specific example that I can talk about it, but we all know that Intel and Cisco, and I know my boss and your boss are talk very often. But it's definitely a very dear and a very close partner.
Let me ask the second part of that question. What are your suggestions for the people who attended this session in terms of educating themselves more about 5G and what's happening? Do you have any particular suggestions?
Yeah, sure. I think 5G is going to touch the life of everybody in one way, not only our personal life, but our technological and our careers, right? And what we work in whatever technology we're working on, 5G is going to touch it one way or another. So the more we all know about 5G, the more what it means for us, the more we can figure out how to make it faster and better. I think that will be rewarding for each of us, but also you never know what that can, if you just think of that little piece of the puzzle that was missing to make it all happen. And I think it's going to take all of us to work together and making it happen.
I know there are more questions, but I'm sorry we ran out of time. I just want to say thank you to Cristina again for coming here today.
Thank you very much. Thank you. It's been my honor and my pleasure. Oh, you didn't have to do that. Oh, thank you so much. Thank you so much. Thank you.
Thanks, everyone.